Hello, favorite students, and welcome to Even More Practice with Ramps. I am on page 22 of your notes pack, and I'm going to be going over number 1. You should first try to do number 1 on your own based on the example video, and after you've tried it, watch this video to check your work. So, in this question, Amy is pushing a 2,000 kilogram truck-shaped boulder. I know it looks like a truck. It's a boulder up a hill at a constant velocity. If there is no friction, what is the magnitude of the force she is pushing with? So it says constant velocity, so we know that the forces, constant velocity, that the forces have to be balanced. Net force has to equal 0, and it wants to know how much force is Amy pushing with. So gravity is going to be trying to pull that boulder down. Amy is pushing up against gravity, and we want to know how much she's pushing with. So the first thing I'm going to do is I'm actually going to erase that. I'm going to draw a new axis. So normally I would have flat ground with X and Y. I'll do it here with my hands, with X and Y. But I'm on a ramp, so I have to turn my X and Y. So X is, we'll say, going up the ramp. Y would be coming out of the ramp. So I've taken X and Y and I've turned them so that X is parallel with the ramp. Or if you like to see it the other way, just like that. Just like that. X parallel to the ground, Y coming out of the ground. Next, I'm going to draw my free body diagram. So I know that gravity still comes straight down. Even though I turn my axis, gravity pulls things down. But normal force comes straight out of the surface, and Amy is pushing up. We're going to say force A for the force of Amy. And I know that I'm going to break my gravity up into an X component and a Y component. So this would be F, G, Y, because it's parallel with my Y component. This would be F, G, X, because I see that it's parallel with my X component. This arrow here is in the same direction as that arrow there. And I know that this space, or this angle, between gravity and the Y component is always the same as the ramp. So that is going to be 10 degrees. What I can do is then I know that the Y component of gravity is going to be mg cosine of the angle, and the X component of gravity is going to be mg sine theta. And now I'm going to draw my free body diagram. So I've got to draw, actually it'll give me a little more space. Let's do it up here. Got to draw my x-axis and my y-axis. So x and y. And I'm going to draw, going in the x direction, the force of Amy. Going in the y direction, the normal force. And going straight down is gravity. But I know that gravity turns into Fgy and Fgx. And that is my angle. So I've got my free body diagram. If it helps to see it turn sideways, that's what it would look like, kind of what we're used to seeing. So I have Amy pushing in the x direction, flat. Amy pushing in the x direction, flat. And I've got the normal force going in the y direction, the normal force going in the y direction. So now I need to do my net force, F net, and the question is asking me for how much is Amy pushing with. I see that Amy's push is in the x direction, so I want to do F net x equals MA. And the problem told me it's going at a constant velocity. Constant velocity means no acceleration. F net x must be equal to 0 because the acceleration is 0. And now I'm going to break up F net x into its parts. So in the positive x direction, I see Amy's push, F A. In the negative x direction, I see the x component of gravity. Not all of gravity, just the x component of it. And that we said here was mg sine theta is equal to 0. And then if I want to get Amy's force by itself, I do FA is equal to mg sine theta. All I did was add mg sine theta to both sides. So this is our final answer, or I guess we could take it even a little bit further and say that FA is equal to 2,000 times 10 times the sine of 10. But I don't have a calculator nearby, so whatever that comes out to be is our answer. We're going to go over this problem a little bit more and problems like it next week in class, but do your best now on question 2 and question 3. Be the leaders your community needs and deserves. Choose to be great and make your dreams come true. Do it.